Welcome to ECLIMU Learning Simplified and welcome to this lesson. In the previous lesson, we discussed one of the graphs in the mirror formula, that is a graph of 1 over u versus 1 over v. And in this case, we said this graph is a straight line graph. If this is y-axis and this is the x-axis, this graph will have a negative gradient where g is equals to -1, representing that the image which is formed by, in this case, a concave mirror is inverted relative to the object. Therefore, if this graph was 1 over u versus 1 over v, then now where this line touches the y-axis, that is the y-intercept, this one will give us the reciprocal of focal length of the mirror. Now, in this lesson, we are going to discuss another graph from the mirror formula, that is a graph of uv, that is the object distance times the image distance, versus a graph of uv against u plus v. And what we are going to realize in this graph, this is a graph which we are going to draw. What we are going to realize is that the gradient of this graph is going to give us, the focal length, since this graph will be a straight line graph from the origin, where the gradient is going to represent the focal length of the mirror that we are using. By the end of this lesson, I expect you to be able to draw and interpret a graph of uv against u plus v, and then use this graph to determine the focal length and the radius of curvature of a mirror. So from the mirror formula, that is 1 over f is equals to 1 over u plus 1 over v. If we add what we have on the right hand side here, if we add these two, we will have our equation equals to 1 over f is equals to the LCM of u plus v is uv. Then how many times does uv goes to u? It goes there v times 1 is going to be v, plus how many times does uv goes to v? It goes there u times, then times 1 is going to be u. So in this case, 1 over f is equals to uv time or divided by u v. Then now for us to make v, this we can solve this to make it linear. Then now we cross multiply. If we cross multiply, this one is going to be f times v plus u is equals to 1 times uv. Then now in this case, if we solve this and start with uv, it's going to be uv is equals to f into v plus u. Then now in this case, if we draw a graph of uv against u plus v, therefore in this case, if this graph will be a straight line, it will be y is equals to mx plus c, where y will be the value that will be in the y-axis, that is uv. Then v plus u will be the value that will be in the x-axis. Therefore, it means the f here, this f here will be the same as the gradient as m, and therefore in this case we don't have c is 0. It means this graph will pass through the origin. Now, if we rearrange this equation, that is uv is equals to f into v plus u. If we make f the subject of the formula, we will divide by uv plus u, v, leave alone this one, v plus u. So in this case, this v plus u will cancel out and we will remain with f is equals to u v divided by v plus u. This equation is very important. We are going to compare it with another equation very soon. So take note of that equation and call it equation 1. So this is the theoretical way of finding the focal length of this from this mirror formula. You add the right hand side, then you make f the subject of the formula. But now if you draw, what if you draw a graph? So what if you draw a real graph here? You are going to have y-axis, x-axis. Then in this case, we have said this graph will come from the origin, or we start from the origin. That is where we have 0. The origin of this graph, that is 0. So if you draw it like that, then now this will be the line. Now this line will start from 0. This one will be V, then this one is going to be V plus U. Remember the units here is centimeter, but the unit in this case we are multiplying length. It's going to be centimeter square. If we are using centimeter, if it's meters, then it will be meter square. Then now in this case, can we try to find the gradient? The gradient of this graph is supposed to change in Y, that is in this case change in UV against change in U plus V. Then in this case we must consider this unit. Here it is centimeter, here is centimeter square. So in this case, if we find this gradient is going to be G, gradient is equals to change in Y over change in X, which is going to be equals to gradient in our case in Y-axis we have change in UV against change in U plus V. This case, this is centimeter square. This one here is centimeter. Then in this case, what we will have, our gradient is equals to UV divided by U plus V. Doesn't matter the units, but now look at this, call it equation 2. Compare equation 1 that we have here and equation 2 that we have here. They look the same. So this means if we find the gradient of a graph of UV against U plus V, it is the same as the focal length of a mirror, and you can prove this either using a graph or by using theoretical method. So this is the first way you can prove that. This is the second way you can prove that. This is theoretical, this is graphical on the right hand side. So we are going to draw a graph and then we are going to see if we can get exactly what we are doing here. And we are going to use the values that we used in the first graph in the last lesson, so that to see if we are going to get the focal length similar to what we got in the previous lesson. So we can handle one question. A concave mirror and an illuminated object are used to produce a sharp image of an object on a screen. The object distance and the image distance are given below. Complete the table and then plot a graph of UV against U plus V, and from the graph determine the focal length of the mirror. So in this case, first we have to fill this table or complete this table. We have a column or a column of U plus V. In this case, we are going to add this U and this V. Then in this case, it's going to give us 100. Then in the second case here, we add this plus this one. It's going to give us 66.7. Then this one is going to give us 78.4. Then the fourth one is going to give us 90.8, then 0.6. Then the last one is going to give us 107.6. Then now the second part is we multiply UV. So we're going to multiply the first value like 80 times 20. And here is going to give us 1,600. The second one is 1,068. The third one is 1,254.4. The fourth one is 1,483.2. Then the last one is 1,724.8. So after you have done that, then now you plot these values on the graph page. Now on the graph page here, you have to draw first the x-axis. Like in this case, if I can draw an x-axis here, like that, this one will be my x-axis. Then I draw a y-axis, and this will be my y-axis like that. So once you draw this one, this y, and this is x-axis, then the first thing you do, you indicate where the origin is, that is 0. Then now in this case, remember they are telling us to draw a graph of UV against U plus V. So the one that comes first, that's UV, is the one that we are going to put on the y-axis. Like in this case, what we have here as UV, we are going to put it here on the y-axis. So here we have U V in centimeter square. Remember, we are multiplying UV, and therefore it's going to be in centimeter square. Then we have in the x-axis, we have U plus V. So you have to indicate U plus V. Then in this case, it's going to be in centimeter. And now what you do, you look at the values that you have and then you choose an appropriate scale. Like in the case of U plus V, the lowest number is 66.7. Then the highest number is 106. So in this case, we can use it without changing it to any standard form. And in this case, we can start with 20, 40. Make sure you do a uniform scale. This is 60. This is 80. Then 100, 120. Then now in the y-axis, we have the lowest number as 1068 and the highest is 1724.8. So in this case, you will realize these numbers are too big to be given a scale on this y-axis. So what we do, we will take these numbers, we write them in standard form. Writing them in standard form, like if we consider this first case here, which is 1600, for us to write it in standard form so that we can form a uniform and an accommodatable scale, we move back 2 times. So it's going to be 16.00 times 10. Since we have moved to the left, remember in standard form, we said you put a positive index. So in this case, this one is going to be 16.0 times 10 raised to power negative 10 or times 10 raised to power 2. So it means what we are going to write here on the y-axis is going to be times 10 raised to power 2. So in this case, if now we write all these values in standard form in the UV column, then this is going to be 10.68. This is going to be 12.44. This is going to be 14.83. This is 17.24. Now, after this, what we do, we write that scale. So the lowest number is going to be 10.68. Then the highest number is 17.24. So now, if we write, we give a scale of this is 5, this is 10, this is 15, and then this is 20. And now, if we plot these values now, it is easier now to plot them. Then if we read here 5, it will be 5 times 10 raised to power 2. If we read 15, it's 15 times 10 raised to power positive 2. So now let's plot these values on this graph. Where we have 100 on the UV, we are going to start with the X. Where we have 100, we have 16. So 100, we move up to 16. This is 15, then 16 is here. That is our first plot. Where we have 66.7, this is 60, this is 70 here, so 66 is somewhere here. Then we have 10.68. So where we have 66.7, we will move up to a point where we have 10.68. 10.68 is somewhere here. And now we have another value where we have 78.4. This is 70 here. 78.4 is here. Then we'll move up to 12.44. So we'll go up. This is 12. 12.44 is there. Then now we will move to another number that is 90.8. Where we have 90.8. 90.8, 90 is here. 10.8 is almost here. Then now the corresponding value on the y-axis is 14.82. 9.8, 14.82 somewhere here. 90.8, it is here. Then the last one is 107. This 107 is somewhere here. Then in 107, we have a corresponding value of 17.24. So we'll move up, then we'll get to 17.24 is somewhere here. This is 17.24. So now after that, what we do, we will join this graph. in such a way that most points are in a line. And remember, this graph is going to begin from the origin, from what we just discussed. So in this case, if we join this graph, then it's going to be like this. We will draw a graph which will run from the origin, then we will draw a line of best fit where we are going to have some of the points on top and some of the points below. And in this case, this is the straight line from the origin, because remember, in this, when we analyze this graph, C was 0. So this graph must start from the origin. Then now after this, what we do, we now find the gradient. Gradient is change in y over change in x. So in this case, if we take 2 points here, like you can take a point on this graph here, we take this point and then we take 0. That will be very easy for us to find. So we will draw a small box here, or a small triangle, and this triangle is very important. It should never be ignored. So once you draw that small triangle, so this will be our change in uv. Again, it's change in u plus v, this case. Then now we find the gradient. So for us to find the gradient, first we pick 2 points or 2 coordinates. At the first point here, up there, here it's the 2 coordinates that we are going to pick here. In the x, it is 80, so it is 80. Then in the y-axis, it is at, this is 10, this is 12, 12.1 or 12.2. This is 12.2. That is for that first point up there. Then down here, the second coordinate we want to use is 0, 0, because we are standing at the origin. And in this case now, for us to find the gradient is equals to change in uv over change in u plus v, which is in this case is going to be change in uv. Remember, now we are going to start with the y, so it's going to be 12.2 minus 0. But remember, we multiplied it in the y-axis. There is a multiplication of times 10 raised to power 2, then divide by 80 minus 0, then we don't have any raised to power here. So in this case, what we are going to get is 12.2 times 10 raised to power 2 is like times 100 all over 80. And in this case, if we solve this one, it's going to be, we can solve it as 12.2 times 100 is going to be 1220 divided by 80. And then in this case, we are going to get this 0 is going to go with that 0, and then 122 divided by 8. Divide by 8. What we are going to get is 15.25. So here we're going to get 15.25. Now, remember what we said from this graph, the gradient is going to represent, let me write G as a capital. So the gradient in this graph is going to represent the focal length. So since we have got the gradient as 15.2, therefore it means the focal length of this graph, the one that we have been asked to find, is 15.2. So F is equals to 15.2, and it will be in centimeters, because remember here the units up here were centimeter square, down here they were centimeter. 1 centimeter will go with that 1 centimeter square, it will remain in centimeters, and therefore it's going to be 15 centimeter. If you are keen enough, in the previous topic or in the previous lesson, we've got a gradient of 16.0. So here we have 15.2. So these gradients are almost, all these values of f are almost the same, only a difference of about 0.8 or 0.5, positive or negative 0.5. So in this case, we are correct. And if you get this one, it's going to give us the focal length. If you find the gradient of a graph of u, v, against u plus v is going to give you the focal length of the mirror that you are using. So that marks the end of our lesson today. In the next lesson, we will discuss a graph of magnification against the image distance.